A group of students from Yogyakarta Tapa are conducting an experiment to measure gravitational acceleration. The objective of the experiment is to investigate the functional relationship between height of fall and falling time. Without wasting any time, let's find out more. So Mimi, what is the other objective the experiment is conducted?
The other objective to the experiment is to determine acceleration due to gravity by studying motion of freely falling bodies.
So, for more information, let's see the slide that have been prepared by students. Okay. So here with me is Amira, one of the students that are conducting the experiment. So Amira, can you tell me what is the theory of the experiment?
For the theory of this experiment, if a body of mass is accelerated from the state of rest in a constant gravitational field, it performs a linear motion. By applying the coordinate system in a way that the x-axis indicates the direction of motion and solving the corresponding one-dimensional equation of motion, we will get...
This is the slide that has been prepared by the student. So, let's go deeper.
For this experiment, we have two main objectives. The first one is to investigate the functional relationship between height of fall and falling time. And the second one is to determine acceleration due to gravity by studying the motion of freely falling body. For the theory of dimensional motion, height is directly proportional to the square of time. This can be displayed by represent of h t power of 2. From the regression line of the data, we can calculate the gravitational acceleration because the slope is equal to 1 over 2 according to equation number 1 at the left side of this slide.
So the apparatus that we use in this experiment is first impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, metal scale, support rod, connecting rod, and ball bearing. For the procedure, the apparatus is set up as shown. Next, the pen is adjusted using adjustment screw under the arrest switch, such a way with 5 cm closest to the stop circuit. The pen is raised by hand after each single measurement.
This is the result that we obtained from the experiment. From the experiment, we make 10 attempts, which is each attempt we make 3 times. And from the 3 time result, we can calculate the average. Also, the average is time with power of 2. For the analysis, the first one, graph. We can plot the graph which is height of fall as function of falling time. And the second one is height of fall as the function of the square of falling time. The second one is using the height of fall as function of the square of falling time graph. The gradient slope of the graph can be determined and the value of g is calculated. The third one is value of uncertainty is calculated, which is g. And the last one is percent difference between the value of g calculated in part 1 above g experiment and the standard value of g standard equal to 9.81 meter per second square. The percent error is experimental value is can be calculated in the next slide. These are the graph that we have been plotted.
For the second analysis, using the height of fall as function of the square of falling time graph, the gradient slope of the graph is determined and value of g is calculated. We use the slope formula which is y2 minus y1 over x2 minus x1. Hence, we got 5 meter per second square. So the acceleration of gravity is times by 2. Hence, 2 times 5 meter per second negative square, we got 10 meter per second negative square. So this is how we calculate the uncertainty for this experiment. Step by step, we got plus minus 0.1 meter per second square. So the fourth analysis is percent difference between the value of g calculated in part 1 above G experiment and standard value of G standard equal to 9.81 meter per second. Percent error in experimental value is error minus theoretical over theoretical times 100. Hence, we got 1.937%. The last one is experimental error is discussed. For the first one, error that has happened while conducting this experiment is parallax error. The apparent shift in an object's position as it viewed from different angles. The second one is random error happened when have numerous amount of uncertainty for height as we increase the height for the ball to fall using a ruler with a precision of 1 millimeter per unit.
Next is the discussion. Based on the analysis, two graphs were generated according to the recorded data. The first graph is the height of fall hm as a function of falling time ts, and the second graph is the height of fall hm as a function of the square of falling time ts square. From the first graph, it showed that the height of fall proportional to falling time, while the second graph, the plotted showed that the height of fall is directly proportional to the square of falling time. From the second graph, the regression line of data height of fall as a function of the square of falling time graph, the gravitational acceleration can be determined. According to equation ht equal to half gt square, the gravitational acceleration can be calculated because the slope is equal to half g. Therefore, from the analysis, acceleration of gravity is equal to 10 meter per second square. Value of uncertainties we calculated by subtracting the average collected data over with the error from the initial experiment. Hence, we get G delta equal to plus minus 0.1 meter per second square and G delta equal to 10 plus minus 0.1 meter per second square. The percentage error is used to compare an approximately value to an exact value. This percentage error can be calculated by using modulus x minus y over y multiplied by 100%, where the x is experimental value and y is the exact theoretical value respectively. G theoretical is equal to 9.81 meter per second square. After the calculation, the value of the percentage error is 1.937%. For experimental error, there are two errors that have been found. The first error is parallax error, that due to mistakes in reading scale. While the experiment was conducted, the height of metal ball has been measured. Then, the parallax error occurred. The parallax error can be minimized by making sure that eye position is perpendicular to the measurement mark. The example of gravitational acceleration are a glass you drop to fall to the floor. Other than that, is a ball you throw in the air to come down again. This happens because there are gravitational force happen on the glass and the ball that makes it move downwards, and the object moves same as the gravitational acceleration.
Action.
The objective of this experiment can be accepted as the height of falling time has a functional relation with falling time. It is proven by calculation that shown in previous slide. From the experiment, the student can determine acceleration due to gravity. G is calculated by studying the motion of freely falling body.